Hey guys, so we are now on the part two, right? We're on part two. We've just finished up with the idea of what set the background, context. We talked about four things. I hope by this time you've evaluated. And now we're about to move on to the scientific revolution begins. When I think about it, I do believe the beginning of this is really about the astronomical revolution, the study of astronomy. This is going to really alter the European paradigm. And I don't know if I did a great job with this in class today, so I'm hoping to have a better conclusion, at least from better than first block. The big conclusion, guys, is by the time we prove the heliocentric theory, I want to make sure you understand that the entire paradigm is going to change. Instead of us being seen as God's creation that dominates the environment and we're so cool and we're the center of the whole universe, we're going to find out that people now begin to believe that we're part of a larger universe. Really, a little bit later when we do some art stuff at the outcome of this unit, we're going to find out that humans felt like they were part of the overall. So we're no longer were we like this great individual. We're going to see that. And it's kind of unique, and it's all about the Newtonian world machine. But I'll see that. So when we look at this slide, astronomy, the traditional view is going to be the geocentric theory, and the modern view is going to be the heliocentric theory. And again, on this side of history, it seems so ridiculous that people were negotiating this and debating this, but it had huge theological, scientific, and intellectual ramifications. So let's go ahead and get started. This is the traditional view of the universe, geocentrism, which means the Earth-centered. It's based on the Aristotle-Ptolemaic geocentric conception. Remember, guys, the humanists believed that Aristotle and Ptolemy were perfect. They were the ancients that were able to disprove the church. But again, if you need to go back to that, that's going to be something else you're going to do. The basic belief is God created the universe. Why would he not put his perfect creation at the center? Despite the Renaissance humanists discovering ancient texts that contradicted this, humanists still placed Aristotle on a pedestal. They weren't going to question him. Just remember, what's that famous painting? The School of Athens. What's the center of all knowledge? Plato and Aristotle. Even in 1521, with that painting, it was still the idea that Aristotle was perfect. Everything he did was perfect. So despite evidence of ancient texts that challenged him, despite the evidence that we're going to see right now that seems to be wrong, they still place Aristotle on a pedestal. This is really bad timing. It's bad science. We can't think something is perfect. We always have to challenge it. But that's the view. A brave person is going to have to step out and challenge the system. He's going to need to step out, and we may or may not agree that Copernicus is that guy. Before we move on, I do want to make sure you understand this is the context. This is the 16th century, the 1500s. We have the Reformation going on, the Counter-Reformation. Think about everything that was once true is no longer true. We're in the middle of the Italian Wars. The sack of Rome occurs just one generation before the publication of some of these works. And think about it. The basic beliefs of the Catholic Church were being challenged. The popes weren't excited about that. By the mid-1500s, under the leadership of Pope Paul IV, we see that the church was having a reactionary movement. We have the Index of Forbidden Books and the Inquisition. And think about this. This is an image to the left. This is probably more or less the Spanish Inquisition, but the same thing was going on in Rome. These are heretics or people who challenge traditions. They're being penalized or punished. This guy over here is getting his feet burned until he confesses that Christ is the real God. This guy over here is being forced to swallow things. This guy over here is hung by his arms. Think about how painful that is. And you might say, hey, Wass, how do we know this occurred? We actually have records of this. There were priests and bishops who recorded all this. So think about that idea that if you're in 1540s and you're thinking about challenging this precious truth of geocentrism, you might see why you might be a little challenged. And the first challenge really comes from a guy named Copernicus. Copernicus is a Polish monk who never really wanted to challenge the church. He, from what I understand, he most likely had this first draft written in 1492, the same year Christopher Columbus sailed the ocean blue, but it won't be officially published until the year near his death, 1543. On the revolutions of heavenly spheres, Copernicus theorized the heliocentric theory. He did base on some ancient critiques of the geocentric theory. He did find, or at least other humanists found before him, these ancient texts that challenged the truths. So therefore, if ancients challenge Aristotle, maybe we should challenge Aristotle. So he theorized the geocentric theory. Now, he was still incorrect. He believed the planets revolved in perfect circles. So could he ever scientifically prove it? Of course not, because he would create a mathematical equation, think that where Saturn is supposed to be. He looked up, Saturn wasn't there. So if you can't prove it through observations or mathematics, it's false. He believed there's a physical substance that held the universe together, kind of like your sixth grade or seventh grade year when you put your third grade, maybe whatever, you put your universe model of the universe together. You had the physical substance that held it together. That's how most people believe that chaos didn't ensue. There had to be something physical that held the universe together. And he did believe heaven was a physical place in the universe. So these are three things that we absolutely know on this side of history were wrong. But again, he still is the guy that said maybe the sun's the center of the universe. Despite his failures, he ultimately does spark ideas in which numerous scientists and monks will begin to challenge and begin to think, is it true? Now, this is the one guy that might not be in your power map because he was not in your focus question. If you don't have him in, perfect, great job. You probably did a better job power mapping than I even did. But I want to point out that Tycho Brahe is kind of important. It's not what his theories were. His theories were kind of whack, but it's what he gathered. So let's quote. I want to point out he vehemently opposed the geocentric theory. He wanted to accumulate the data to prove that Copernicus was a wacko and wrong, heathen, deserving to go to hell. Unfortunately, as he set up that castle in Denmark, as you read, and he took mounds and mounds and mounds and mounds and mounds of data. What did he collect again? Data. Once again, what did he collect? Lots of data. Once again, data. He recorded all his observations, thousands of pages of data, and his whole point was he was trying to disprove Copernicus. Unfortunately, he was never able to successfully prove the geocentric theory. So this is where he comes up with the odd view. And I would argue this is bad science. He knew what his data did, and he tried to force his data into a unique look. His unique view was really weird. You see 2 points of motion. Here's the Earth, the moon, and the sun revolved around the Earth, while all of the perfect other heavenly bodies revolved around the sun. So it's kind of like the heliocentric theory, but it still proves that this Earth was the center. Really weird stuff. But regardless, his conclusions were way off, did not line up. But when he does ultimately die, his data lives on. And why is that important? Well, it's important because the next guy, Johannes Kepler, he developed these things called 3 laws of planetary motion. You don't need to define all 3. We're going to just say this, all right? In his 3 laws of planetary motion, he discovered that planets revolved around in elliptical patterns. Rather than perfect circles, they were more like ovals. Because he knew this, he then was able to create a mathematical equation, and through those algorithms, I guess they're called, he was able to prove without any doubt that the Earth was not the center of the universe and the sun was. It's interesting, but I want to point out this is not revolutionary because he did publish his works in what we call jargon, and jargon is professional language. So what is professional language? Professional language is language only directed for scientists, so the average person who could read probably wouldn't read this. This was just about science. And this is going to allow scientists to mathematically prove the heliocentric theory. I've already said that. I just want to point out, he prints these out, he sends them out to his friends, and his friends challenge him. They want to make sure that he's right, and ultimately he's proven. One of his friends was Galileo. Galileo, he is the first European to use the telescope. We see here he's in a negotiation with the Pope, most likely. And Galileo, in 1610, published his early findings. You've already read this. I hope you have this power map. But in the Starry Messenger, he actually invalidates the geocentric theory. How does he do this? I'd actually say 3 ways. Number 1, he observed 3 moons around Jupiter. Well, if he's observing the moons revolving around Jupiter, it invalidates the geocentric theory. According to the geocentric theory, all heavenly bodies revolve around the Earth. Well, once he realizes through observation that there's planets revolving and moons are revolving around Jupiter, then it could be concluded that geocentric theory is wrong. Second thing, all heavenly bodies were perfect. Well, he saw the sunspots in the sun, and he saw the craters on the moon. So he now records other ideas in which clearly heavenly bodies weren't perfectly. So, with the moons around Jupiter, sunspots, and the craters, he ultimately invalidated the geocentric theory. The church was kind of taken aback. They were like, what's this going about? I want to point out the starry messenger was not the shock. It was the dialogues of the two chief world systems. And you can just call them the dialogues. He published this in 1632. He did feel like he had permission from the Pope, who was a friend of his, Pope Urban. I think it's Urban, I forget, maybe Urban the Sixth. But Pope Urban and him were basically drinking buddies, from what I understand, when they were younger. And he thought the Pope said, cool, you can do something that challenges the religious world. Unfortunately, the Pope did not say that, and the Pope never realized that this was what he gave permission for. In the dialogue of the two chief world systems, I want to point out that Galileo basically said the church view was simple-minded. Simplico. I hope you guys noticed that. Simplico means simple-minded. This was really frustrating, and since this was published in the vernacular, or the everyday language, Italian at the time, average people were able to read it. So this sent shockwaves into it. And by 1632, we're in the middle of the 30 Years' War. The Pope is really concerned about his authority. Is Christendom going to ultimately shatter? He's not sure. He's worried. So this kind of contributes to that reactionary view. So therefore, he was forced into the Inquisition. Galileo was invited to the Inquisition. At the Inquisition, he was forced to recant his scientific beliefs. I do believe in the outcome. He was like, hey, it is what it is. He had already said that the Bible is about to get into heaven. It's not written about the heavens. He already saw a separation between science and religion. So when the Pope said, you got to recant, he's like, it's cool. He recanted. It is recorded that on the way out, he said, yet it still moves. It being the earth, it's his idea of giving the finger to the church. Yeah, I can recant in words, and yet in reality, I am not wrong. The earth moves. Heliocentrism is true. But he spent the rest of his life under house arrest. He studied motion. You probably have inertia. He also studied gas. A little fun fact, as he was, there was always two guards outside his house, from what I understand. And what he did, he created a balloon that looked a lot like what Satan would look like. He put the helium in the balloon. The balloon would go outside of his chimney. Then one of the guards would scream because he feared Satan was there. He would then let out the helium. The balloon would come back down. And as the other guard gets the other guard's attention, the guard looks up and goes, what are you talking about? And they would make fun of him. So if you want to know more about that, you can definitely check it out. Galileo is an amazing individual. Unfortunately, it also marks the apex, the climax of the intellectual world of Italy. In the end, Galileo provided the observations that invalidated the geocentric theory, while the reactionary Catholic Church made decisions that caused Italy to lose its academic importance. So by this time, Italy is being left behind. It was left behind politically, culturally, religiously, and now it is academically. Italy will not be spoken of until the 19th century. I hope that makes sense to you. Let's go ahead and move on. So now we have observations that the heliocentric theory is right. We have observations that invalidate the geocentric theory. But now the question is the why. Why and how does the universe move? This is where Sir Isaac Newton comes in. Sir Isaac Newton publishes this key work called Principia, the last intellectual work written in Latin. I think it's kind of cool. And he publishes his work in 1687. This is right about the same time as the Glorious Revolution. One of his friends is a guy named John Locke. You may have heard of him. So there's a lot of stuff going on, and it's about the stability of England that allows things like this to occur. But with Principia, he introduces what we know as calculus. And in calculus, he developed a mathematical equation that proved the universal law of gravitation. And the universal law of gravitation is the natural law that held the universe together. I'm going to say that again. The universal law of gravitation is the natural law that held the universe together. He has now mathematically proved the how and why of the universe. Through the development of calculus, and you were able to do this, he was able to prove the motion and all that cool stuff. And we developed this thing called the Newtonian world machine. I hope on the entry ticket, which is now an exit ticket, you'll be able to do. I want to point out the Newtonian world machine is the idea that the universe is a machine created by God, controlled by natural laws. And we can find these natural laws through observation and mathematics. So the Newtonian world machine is the idea that the universe is one ginormous machine created by God, controlled by natural laws, and through mathematics and observation can we find all truths. That's kind of an important thing. So as we conclude, I am going to conclude a little bit better than I did first block. I want to point out at the outcome by 1687, there's a new faith in science. The idea that all truth can be found mathematically and through observations. And if you can't do it either way, then it's no longer true. There's going to be an overemphasis on reason and logic. So I hope that makes sense. And I'll be right back with you guys in the last video.